In this video, I'm going to work the odds of the review so that you can see at least one of them. So first it says, determine if it's growth or decay. And remember, that's the number being raised to x. If the number being raised to x is greater than 1, it's a growth. Less than 1, it's a decay. So 2/3 is 0.666, so that would be a decay. So b equals 2/3, which is less than 1, so that's a decay. Transformations. This is going right 1 and down 6. And I usually plug in -2, -1, 0, 1, and 2. But since I'm taking it right 1, I'm going to add 1 to all of these. So the numbers I am going to plug in are -1, 0, 1, 2, and 3. So -1, that'd be, I'm not going to waste your time. I'm just going to put it in the calculator. Put that back. So I said right 1, down 6. Wait. Up. It's left 1. Control T. Oh, I'm sorry. Try this again. Left 1. So I should subtract 1 from my x's. So that gives me -3, -2, -1, 0, 1. So -3, I'll say -5.8, -5.6, 8, -5.6, -5, 0, -3, -3, +3. There we go. There's some 5 points. So that's what I'm asked for. 5 points. -3, -5. It's basically -6, but it's up just a tiny bit. Just a tiny bit higher. -1, -5, 0, -3, 1, 3. There you go. And don't forget your asymptote. Your asymptote is usually at 0 unless it's moved up or down. So this one was moved down 6. So here's your y asymptote. Draw your asymptote. So that's y equals -6. So with exponential, you have a horizontal asymptote. It shouldn't curve up like that as you keep getting closer and closer. Never crossing, but closer and closer. I'll take it. Looks good enough. Domain, all real numbers, left forever, right forever. Or infinity, positive infinity. Range, start at the bottom, work your way up. The first thing you get to is that asymptote at -6. So parentheses, because you'll never touch -6. It'll be like -5.999999999, but it'll never get to -6. Your calculator will eventually round to -6, but it's not actually getting there. And then it goes up forever, positive infinity. As x goes to the right, so as your graph goes to the right, your graph is going up, and up is positive infinity. As your graph is going left, your your graph is getting closer and closer. Your y values are getting closer and closer to your asymptote, and your asymptote is at -6. Y-intercept is when x equals 0. Let me find that. So that's how I expect you to do on the test. Hopefully without messing up like I did. All right, log 2. If it is not in parentheses, this is just taking the log of x, not x minus 3, just so you know. So this is what we were doing yesterday after the quiz. 2 is being raised to some number, is the inverse. So that's the inverse. -2 squared is 1/4. 2 to the -1 is 1/2. 1, 2, 4. It's the inverse of log base 2. So y of log base 2 of x inverse. You switch it. So 1/4. But we're graphing, so I don't want to put 1/4. I want to use decimals. 1, 2, 4. And then your translations, you have to know. I will ask for your translations. Down 3. So down affects the y's. So I'm going to subtract 3 from all my y's. So is that -2, down 3, -5. Down 3, -4, -3, -2, -1. Okay, remember your log asymptotes are at x equals 0 unless it moved right or left at all. This one's not moved right or left at all, so my asymptote will stay at x equals 0. So here's my asymptote, x equals 0. .25, -5. Close. 0.5, 4. Closer. 1, -3. 2, -2. 4. 1, 2, 3, 4, -1. It's asked for the x-intercept. X-intercept is when y equals 0. So it's asking when this equation 2x minus 3 equals 0. So just like solving our other log equations, you have to get log by itself. So I'm going to add over my 3 and then write an exponential. 2 to the third equals x. So x would be 8. 80. Or go to the calculator and graph it. Graph. We're doing log base 2 of x outside minus the Control T. I hate that it's doing that, but that's 0. That's saying 0.000000001. Negative that, but that's 0. But if the graph isn't being nice, again, you can go menu, analyze, 0, left, right, and you get your answer. So don't forget we can do that in our calculator too. And we can also do menu, trace, graph trace, and you can type in any number you want. So if you want to type in 0.25, you can, and it'll give you a point at -5. You can type in any point as long as you get 5 points on this graph. And make sure you have your x-intercept. So this is a 10 by 10, so 10, 9, 8. So it crosses over there. Domain, start on the left, work your way to the right. The first thing you get to is your asymptote at 0, and it goes on forever. Can't touch your asymptote, so it's a parentheses. Range is going down forever and up forever. Remember, end behavior switch. Now it's saying when your y is going to positive infinity. So when your graph is going up, my graph is going up, where's my x's going? My x's are going up. And my graph is going down, my x values are getting closer and closer to my asymptote of 0. So there's your log. I'm going to keep going. Write it in log form. So let's write it one more time. Log base b of a equals x. So b to the x equals a. That's how we're going to switch back and forth. So the b of your exponent, the b of your exponential becomes the b of my log. The b of 64 equals 2. So the 2 is in the x spot, so that's what it equals. And equals 64 is now what you're taking the log of. Log base 10. I'm not going to write it. It's not wrong if you write it. You won't get points off or not. But there's always an invisible 10 there. So 10 raised to the 54 equals 2x. Okay, so that's 10 raised to the 2x equals 54. Right, an exponential, 3 raised to the third equals 27. 4 raised to the x equals 90. Remember, your natural log has a base e, so hopefully that'll help you. Evaluate. Use change of base. So b to the x equals a. Formula when necessary. 9 raised to what gives you 81? 9 raised to what gives you 81? And that's 2. 9 squared gives you 81. So 2 is my answer. 5 raised to what gives me 1 over 25. So it's negative because it's a fraction, and then 5 squared is 25. So negative 2. And always check your answer. Remember, it's 10 if it's not written. So 10 raised to what gives me 63? Nothing. Nothing works here. So if it's not nice, then we have to go to the calculator. Log of 63. Log 63. 1 point, I'm going to write it all, 1.799934, because 10 raised to the, if I just 1.8, that's not going to be 63. See, the longer I write my decimal, the more accurate my answer is. So I'm going to 1.79934. Much closer. 1.79934. So you're probably saying, well, then why didn't you put these in the calculator? You could, but I want you to know what log means. Log base 7 of 28. 2 of 70. Log base 2 of 78. 2 raised to that number gives me 78. I'm going to write the whole thing. 62854. Okay. Keep going. Product rule, remember when you're multiplying, it expands with addition. If you're dividing, it expands with subtraction. And if there's a power, the power gets multiplied to the front. Okay. So if we're condensing into one logarithm, we need to bring the 3 up to the 2. So log base 2 cubed. And 2 cubed is 8, 2, 4, 8. I'm going to go ahead and write 8. And then write it as a single log. So log base 8. Multiplying, because it's addition, x minus 4. And then distribute your 8. So 8x minus 32. There you go. All right, bring the 3 up. Bring the 3 halves up. So we have the natural log of 6 cubed minus the natural log of 4 to the 3 halves. Hi, buddy. I put this in the calculator and I got 216. And I put this in the calculator and got 8. Then when you condense it into one log, you divide it. So 216 divided by 8. And I'm going to stop this video on this question. Do you have to go potty?
Yeah.
All right, good. And you get 27. So that'll be what you're taking the natural log of. Natural log of 27. Okay? Next video, we'll do the next odds.